Yeah. First, let me explain why this primary indexing many times it cannot solve our problem. Because if we need to create a primary index, we need to make sure the indexing key, the key must be ordered in the original table. Yeah, that condition is very strong. Yeah. Usually it is hard to satisfy that condition. Yeah. So that in a general situation, the search field may not be ordered in the original table. Yeah. So most of the time we need to create an index file based on an unordered search field. Yeah. So to do that, the only way is this dense index. Yeah. Let me explain. Yeah. Why we need a den and the meaning. Yeah. So I will explain the meaning. Yeah. So some of you may forget so what do you mean dense, right? Yeah. So we will get there quickly. All right. For the dense index, yeah, this index file has this property. Yeah. It has an index entry for each search key value, and hence every record in the data file. Yeah. That's the main property of this. Yeah. So if I draw a simple diagram, yeah, so you can see. Yeah, let me see. Draw a simple diagram. Okay. All right. So we have. Yeah. Let me do it here. Get a comfortable position. Oh, sorry. Yeah. All right. For the index file, yeah. Let me draw index file first. Index file usually much smaller than original file. Yeah. Two fields, the indexing key field and the pointer field. Yeah. Original data file, yeah, so usually we have many fields. Okay. All right. Like that. All right. Many rows. All right. Now, let's consider one particular search field, and then we use it as the indexing field. And this field, we assume unordered. Yeah, because in general, it is unordered in the original table. Now, we want to create an index file based on this search field. Yeah, this is index file. Yeah. So here's the problem. If we do the search based on the search field directly, we cannot apply binary search. It's not ordered. Yeah. In order to apply the binary search, we have to sort our data based on this field, search field. We need to sort it. Yeah. But when you sort it, you cannot sorted in the original table because we don't want to change the original table. So you can only do the sorting in your index file. Yeah, here. In the index file, you do the search. Okay? So this is the indexing field. Yeah. Yeah. Make it ordered. Ordered key field. Right? Make it ordered. Yeah. Then you can apply the boundary search. Yeah. All right. So then, now the question. Now you can see the question. In order to find any particular row with given key value, given a key value, in order to find it, yeah. So you have to find the location. You have to find the location in this index file. Yeah. All right. Yeah. So because here there is a problem in the original table, the data is not ordered. If it's not ordered, you cannot make prediction based on the order information. No prediction can be done because our prediction, we need to use the ordered data to make our prediction. Now the data cannot make prediction. If you cannot make prediction, then you need to store the location of all the rows. In the original table, location of each row, you need to store the pointers in the index field. Yeah. Yeah. So each entry stores a pointer that points to the location of one particular row in the original table. So you have to make one-to-one correspondence. One entry corresponds to one row, one record in the original table. One-to-one correspondence. In that way, when you search the index file, so you apply the binary search on this in a key field, you can find its location quickly, right? So then you get a pointer. So the pointer tells you the location of the row in the original data file. Then you find it. Yeah. So in this understanding, you can see we have to apply index. Yeah. So this condition means dense. Yeah. This condition, one entry for each search key value. That's the dense property. Sparse, you can see, sparse, the number of entries is less than the number of records. That's sparse. Here, the number of entries equals the number of rows, records in the original table. That's dense. Yeah. All right. So after you understand the main property of the dense index, yeah, so now we can do comparison. Primary index is not dense because we skip many rows in the original table. We do not need to store the locations of all the rows in the original table because we can make prediction based on the ordered data. Yeah. So we can save a lot of storage. Okay? Yeah. Yeah. So last time I gave you an idea. In 1/20th, 1/30th, in that level. Okay? Yeah. All right. So then, yeah, but the correspondence for the primary is one index entry for one block anchor. Yeah. Last time I gave you the meaning, a block anchor. Yeah. Block. Yeah. Anchor record in the block, the first row, the first row in that block we call the anchor block. Okay? So that kind of one-to-one correspondence. One block usually contains many rows, many records. Yeah. All right. Then sparse index. Yeah. With sparse index has index entries for only some of the search values. So we skip many search values. Only for those search values corresponding to the anchor rows in the blocks, in those disk blocks. Yeah. Some of them. So we skip many search values because we can make good prediction based on the order information. Yeah. All right. Comparison. Yeah. Yeah, because we need to compare when we do the search, how many comparisons do we need? Yeah. So a dense index, yeah. So because dense index, our data size of the index file relatively larger. Yeah, because we cannot skip any row in the original file. Yeah. So relatively larger than the sparse index. Yeah. So in that respect, in that aspect, it looks a little slower, right? When you do the binary search on a larger index file, a little slower, but don't worry too much. Yeah. But a dense index supports unordered file. Yeah. So we need to do a few more comparisons, but it is still a powerful way to speed up the search in the original file. Yeah. Yeah. And the good thing is the dense index, we can apply it on any unordered field. Yeah. If there is a total order for the domain of the search field, yeah, in general, most of the time we have ordered, total order. Yeah. Only in very small percentage, rare case, the search field may not have any total order. In that situation, we need to use the hashing technique. Yeah. Hashing technique. Yeah. All right. Yeah. So it can still we can still apply indexing technique, yeah, but based on hashing technique, not binary search algorithm. Yeah. All right. Then, given, yeah, so here we're back to, this slide I talk about the prediction problem. Yeah, so we can make good prediction for those roads we do not store their locations, yeah, but we can make good prediction. Yeah. All right, how to do it? Given a search key K of a record. Yeah. All right. Then we go to our primary index file. Assume that a primary index is constructed based on the field. Yeah. All right. Then do the binary search on the primary keys to locate the position. Yeah. So log base 2 of n. Yeah. All right. So we can find the given key in the interval between two adjacent primary keys of the index file, primary index file. Yeah. Okay. Yeah. So the binary search, yeah, we can get this inequality. After that, we need to make prediction. Okay. All right. After that, then so here because we assume that, right? Yeah. So here just remind you, in order to apply primary index, construct primary index, you need to make sure the indexing field of the original data is ordered. All right. So then we get a point P of I. So here, not a P of I plus 1. So we need to retrieve the pointer from corresponding to K of I, the entry. Entry with index I. P of I. Okay. Because this K of I, remember, this K of I pointer point to anchor record. Anchor record. The first record in the disk block containing search key K. The first one. All right. This block containing record. So here, let me draw a simple diagram. All right. Suppose this is one disk block. Okay, this disk block we use it to store the original data file. I need to. Original data file. Okay? All right. Remember, in the original data file, it is ordered. Okay? Because we assume that. We assume that ordered original data. Okay? Otherwise, you cannot apply primary index on it. Okay? Ordered. Then this one, location, P of I point to this location. Okay? All right. P of I. So this. So you get a location of the whole block. So this is the anchor block. Anchor record. This is anchor record. Okay? All right. Anchor record. All right. Then your search key K, somewhere between, right? So this is the record containing the search key K. Somewhere in the middle. Okay? And in your primary index, you do not store the location of this K, search key K, directly. You do not store. But you can make good prediction on it. So you do not store it directly. All right. Then, after you find this anchor record, you just load the whole block into the main memory. Okay. Load the whole block. Load it into main memory. Okay? Because the row to be searched for must be in this disk block. You know it. Based on inequality, you know it. Okay? It must be in this disk block. Then you find it in the main memory. That's much faster. After you load this disk block into the main memory, then you do the search in the main memory, you can find it quickly. Okay? Yeah. Yeah. All right. So that's the typical. So why we can make prediction? Yeah. Because we have the given ordered information. We can easily tell the search which disk block contains the row to be searched for. All right. Yeah. Then, yeah, so load into the memory. Yeah. So then we find the record in main memory. We know it's much faster. Yeah. Remember, I gave you an approximate number, 1 to 100 ratio. Okay. Yeah. That means one main memory access is 1/100th of one disk access. Yeah, 1/100th. Yeah, disk access. Yeah, much faster. Yeah. 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 So when we do the search in main memory, yeah, so we don't worry about the number of comparisons. Yeah. You can also see when we do the search in main memory, we can still apply binary search, right? Yeah, because it's ordered. Yeah, we can still apply binary search. Yeah, yeah. Although that number is relatively small. Yeah, but yeah, we can. Yeah, but for the dense index, then when you do the search in the main memory, you need to do sequential search. Yeah. You need to do sequential search because there is no order. No, so the rows are not ordered based on the search field, then you can only do the sequential search. The good thing is, in main memory sequential search, on small number of rows, very fast. So we don't worry about the performance, won't be slow. Yeah. All right. So that's the. So you have the. All right. The last thing, major problem with a primary index. Yeah. 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 Some problem. So we need to consider. Yeah. All right. Several problems. The first one, some problem occurs when data is added and deleted. That because in the real world applications, we need to work on the dynamic data. Yeah. The typical real world situation. So we work on the dynamic data. So that means we need to keep adding, deleting data. Yeah. So we need to consider. Yeah. But think about your primary index assumes ordered data. But after you add in a new row, how do you guarantee your table after adding new row still ordered, right? Yeah. Yeah. So you need to recover the ordered property after you add a new data piece. Yeah. That's relatively hard. That is relatively hard. Hard, that means you need to do a lot of work. Okay? Yeah. So that's the first drawback. Deletion, yeah. Actually, deletion problem. Deletion also you have problem. Think about why? Yeah. Because deletion, we know we do not break the ordered property, right? Ordered property. After we delete one row, all the rows, all the remaining rows are still ordered, right? But there is a problem, space usage problem. Think about it. For the deletion, yeah. If, think about it. So you have one page, right? Yeah. So your rows, order the rows start here. Think about after you delete one of the row in the disk block, then this slot is unused, right? After deletion, that row, that location, that slot is unused. Do you want to rearrange your disk block, the rows in this disk block to save some space? If you need to rearrange it, then very time consuming. Yeah, because you need to copy some rows, do the shifting. Then a lot of copy work. That's not convenient. Okay? Yeah. So deletion, you may cause problem. Insertion, also you cause a lot of problem. You need to do a lot of data copy work. Yeah, that's not convenient. Yeah, very slow. Yeah. So that's the problem, drawback for the primary index. Yeah. Yeah, so that's the typical problem for ordered files. All ordered files, when you need to do insertion, deletion, you have this kind of problem. Okay? Yeah. So you need to find a solution. Yeah. You need to find a solution. Okay? Yeah. All right. After insertion, deletion, to recover the order structure, the cost is high. Yeah. So is there a way to solve this technical problem? Yeah. 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 So that is a challenging technical problem. Yeah. Yeah. But there is a solution. Yeah. So later I can talk about the solution. All right. Change in primary index. Yeah. So you need to make adjustment, make change. Actually, a lot of change. Yeah, not a small change, big change. Yeah. All right. Move records to make space for new record. Yeah. This is not a good way. Yeah. So if you just do, copy records from one location to another location, so this way is not efficient. Okay. Yeah. Change anchor records in some disk blocks. Yeah. Still not efficient. Yeah. When you do things like this, not efficient. Okay? Yeah. All right. Change some index entries, also not efficient. Yeah? Yeah. Okay, all right. All right. So then, more advanced data structure is needed. Yeah. Here I can say a few words about the more advanced. I mentioned before, right? B tree, B plus tree. Yeah. Multi-level. Yeah. Yeah. So here, more advanced. So that's the B tree and the B plus tree. B plus tree is improve the B tree. Okay. Yeah. Improve the B tree. Yeah. B plus tree. So that's the multi-level structure. Yeah. So, okay, yeah. Top, the root node, one root node, then many branches. Okay? Yeah. Hundreds of or dozens of, okay, in that level. Yeah. Hundreds of or dozens of. Yeah. All right. So each level, yeah, like that. Same number of branches, okay, each node. Yeah, because you can calculate the number of branches for each node. Yeah. Yeah. Going down, okay? All right. And as I said, because the number of branches usually is a relatively large number, so 4 or 5 levels, you can handle billions of nodes. Billions of nodes. Billions of nodes. Okay? All right. Then, yeah, so before I finish this part, yeah, then I need to talk about insertion and deletion. Yeah. So why people design this super complicated data structure? Yeah. To handle dynamic data efficiently. Yeah. The main reason people use this super complicated data structure in order to handle insertion, deletion quickly, yeah, in an efficient way. Yeah. Yeah. Here I just, give you some very high-level description, yeah. Not too much detail. Yeah. All right. When you do insertion, all right. Yeah. So here, the design of this structure, data structure, is very smart, very smart. Yeah. So here I just give you some main properties. Yeah. So we don't want to get into too much details. Yeah. As I mentioned before the COVID time, actually I talk about a lot of details of B tree, B plus tree. Yeah. I even assign a lot of calculation questions on B tree, B plus trees. Yeah. So a lot of hard work there. Yeah, but after COVID, so then I cut off most part of this topic. Yeah. All right. Why? Yeah. So smart. First, each node, it is not full. We know each node there is some capacity number. Each node can hold number of records. Yeah. Number of let's say entries. Okay. Yeah. Let's use entries. Index entries. Yeah. Each node can hold certain number of entries. Ordered. Yeah. Those entries are ordered in a node. Yeah. But there are some room to store more entries. So it's not full. The capacity, it's not full. Yeah. So when you do the insertion, when you insert a new entry into that node, you just put it in the empty location. You're done. Okay? Yeah. No adjustment. Yeah. All right. But when you do the insertion more and more, sooner or later, you fill the capacity of the node. Yeah, because it's full. Yeah. The capacity of that node is full. After it is full, then when you insert another new entry into it, you need to split the node. Okay? So there is an algorithm describes how to split a node, 1 into 2, still preserving the structure. Splitting. Okay? All right. Yeah. Yeah. Then, after the splitting, so, you still get a original structure. Yeah. The structure property, all the properties of this tree still preserved. But you need to do some local work. When you do some work, right? But it's a local work, not global work. Okay? So you move a few nodes locally and not globally. Global, too much work. But when you do some adjustment work locally, not too much work. Yeah. That's the insertion. Then deletion. Deletion, when you make a deletion, so you go to the right place, the right node, so you delete the entry, right? You need to make an adjustment. All right? So in the normal situation, you just do the deletion and adjustment in that node directly. Okay? Yeah. But think about when you do more and more deletions. 1 to there. Your node, the number of entries stored in one node becomes smaller and smaller. Then there is some consideration. Yeah, because you don't want each node store the number of entries too small. So you put a lower bound. You put a lower bound for each node. Yeah. Higher bound, you have a capacity, right? You have a capacity number. That's the higher bound for the number of entries. There is a lower bound. That's half of the capacity. Okay? Yeah. You want to control. Yeah. You don't want to make each node, the number of entries stored in each node, too small. So you use a lower bound, half capacity lower bound to control. It cannot, after the deletion smaller than this lower bound, then you need to merge two adjacent nodes. You need to do the merge, okay? Do the merge. Yeah. So then you also adjust locally. It's a local operation. Yeah. So that's the idea, how to manage insertion and deletion efficiently. Yeah. But it's very complicated. But it can be done. Yeah. So after those detailed steps implemented, then so you can get B tree, B plus tree. Yeah. Very efficient. Yeah. Small number of binary searches. Yeah. And you can cover large data file. Yeah. All right. Yeah. So that's the. So we finished this topic. Yeah. Next, I have half an hour. I only want to talk about one coding question. Yeah. Last time I couldn't find time to explain the structured data transmission questions in the project, because I use a special method. Yeah, I need to explain that. Otherwise, you may feel weird. Yeah. All right. So let me go to the code part. All right. Then here I mainly talk about data transmission. Yeah. So there is some problem. So when we send data, think about when we need to edit one row of data. One row contains multiple fields. How do we send multiple fields from client side to the server side? Right? Yeah, multiple fields. Because multiple fields, we want to use an array to store it, right? Yeah. One array. Yeah. So array, it's a structured data. Yeah. Structured data. There is a structure. Okay? Yeah. Yeah. So then the most convenient way to send an array, we need to use JSON format. JSON format. That's the best way to send. Yeah. Yeah. But here, if I want to use the JSON way, I need to spend a little more time to explain this technique. Yeah. So yeah, it takes some time. Yeah. Although it's not very hard. Okay. The structure simple. Yeah. Yeah. But with the limited time we have, so I want to skip that part. Okay. Skip that part. So then I use a temporary solution. Yeah. It is not as good as the JSON way. Yeah. So it's not as good as JSON way, not as robust as the JSON way, but it is pretty close. Yeah. It's simple, and it is very close to the, the JSON way. But we do not need to spend quite some time to study the, how to send data, receive data, from JSON objects. Yeah. So here we just send a string. Okay. Yeah. One string. Yeah. One string, no problem, right? Yeah. But this one string, we need to store the values of multiple fields, not a single field. Single field, that's easy. But you need to store your data in multiple fields. Yeah. Then, so here, the easy way I use a special delimiter. Look at this symbol. Yeah. So I just create some, special delimiter because I use some different values of different fields. Yeah. Separate. Yeah. All right. So then I do the concatenation. Yes. So, yeah. I do the concatenation. Yeah. Because here, after we send a request at the server side, then we need to retrieve the data. This is the retrieve the data, response text. This object contains return the data from the server. Yeah. Here, I can show you the server side. Server side, let me look at the server side, okay? Server side here. Get the data by row, okay? Let's look at the PHP file here. Get the data by row. Yeah, here. Yeah. So we get a FD1, FD2. Remember, we need to use the data of the first two fields to identify the current row. Yeah. Then we do the query. Yeah. So this query, when we do the query, yeah. So we use the data field 1, field 2 to find the data from the right table and the right row, this query. After that, we need to send it back to the client side. Before we send it back to the client side, we use a for each loop, okay, to do the concatenation. Dot operator in PHP, it's a concatenation operator, okay? Connect them. Yeah. So each field value _value. So we concatenate the field values for the whole row, yeah, using this special symbol to separate two adjacent field values. Yeah, just simple way, yeah, because here we do not need to use the JSON object, okay? Yeah. So in this way, yeah, so you can use other different symbols, yeah, but make sure the symbol is rarely used in your data because we don't want to mess up, right? If you use some symbol that may appear in your data, then you mess up, okay? So the symbol you choose, you want to make sure the chance the symbol appear in the data is very little, minimal, almost none. Yeah. All right. Yeah. So then we can make the data of the whole row in one string. In this way, this $out variable contains one string containing all the values of the fields in that row. Then print, yeah, print. So at the end, we just output. This print means output, okay? Yeah. Push it out, yeah. Because when you do the communication between client and server, there is a, connection object established between client and server, okay? There is a connection object. Yeah. So you print, send through the connection object from server to client. Okay. Server to client. Yeah. Yeah. All right. In that connection object. Yeah. All right. Yeah. Some socket. Yeah. Lower level details you do not need to know. Yeah, but it's there. Okay? Yeah. Socket, yeah, through, that kind of details. Then at the client side, yeah, so we go back to the JavaScript file. The client side, we are here. Yeah. So this line, you retrieve the data from that connection object. Okay. Yeah. Yeah. You're listening. Yeah. So you're waiting. Yeah. Waiting the data sent from the server side. All right. So you retrieve the data. Okay. Response text. String. Yeah. This dot response text. Whole string. Then you need to split the string using the delimiter. Is used as the delimiter. So you split a string into an array using this symbol. Okay? Yeah. That's simple. That's the idea. Okay? All right. Row array. In array, yeah. So split function, JavaScript function, you call split. You get array. Okay? All right. So this array, you get the number of elements in the array, dot length, number of elements, because you need to store that value. Yeah. Because when you do the for loop, you need to use that number of fields. Yeah. So you need that number. Okay. All right. So then you update, you modify your user's interface. Yeah. So you know that's the details, how you modify the user's interface. Yeah. So this element, yeah, because I create ID, yeah, capital R refers to row number. Row, this U, the specific row number. R plus row number, column C, column number, plus I. Yeah. So you identify which row, which column, then you put the content in that cell, table cell. So this is the specific content in the table cell. Yeah. All right? So, yeah. So then you change the display non-block, you flip. Okay? So one div, you make it invisible. Yeah, you hide it. Another, you show it block. Okay? So you flip from one to the other. We put two div elements there. Yeah. So it's this way. Yeah. So here the main explanation I want to do is this special delimiter. Otherwise you feel weird because nobody using this way. Yeah. It's a temporary. I said it's a temporary solution. Yeah. Yeah. It is not as robust as the JSON way. Yeah. JSON way. So you do not have any problem all the time. Here, because the potential problem is if this special symbol may be part of your data, then you get trouble. Okay? Yeah. Yeah. So the only problem is if this is part of your data. Yeah. So you want to avoid that. Yeah. You need to choose some special symbol that can never appear in your data. But after, first you get a temporary solution. Yeah. Later, when you have more time, you need to convert it to the JSON version. Then it's much better. Yeah. Yeah. So that's the, so the main thing I want to explain. Yeah. All right. Then another thing, before I move to the next question, another thing I also need to explain. Yeah. So this actually this update function similar to the previous one, but this time we need to send a string containing. Question? Yeah. Oh, no, okay. Oh, yeah. All right. So here, because when we click the update button, we need to send new the server side, right? From client side to the server side. So in our update function, we need to form a string, concatenate the values of all the fields in the current row. Yeah, so we similar. Yeah, but this time I do slightly different. Yeah, symbol. Yeah. But the idea is the same. The concatenation. Okay. First, we use a for loop. Do concatenation, connecting all the values of the current row. Okay. Yeah. All right. Then, after that, we need to send the data. Yeah. So this URL contains the data. The URL, field 1, X value. Remember, we use field 1, field 2 to identify the current row. Yeah. Then, the field 1, field 2, that's the old values. The two values of, two fields of the old row data. Okay, older row data. Then this DAT, that's the new, updated, new values of all the fields in this row. Yeah. Then, okay, yeah. So the URL. Then we send to the server side. All right, send to the server side. Yeah. Because when we do update, think about server side, we have a set data by row PHP file to do the update operation. After that, for the update operation, we do not need to receive the return data, right? Yeah. So you just send the data, but you do not need to process return data. Okay. So no return data processing, but we need to update our GUI a little bit. Yeah. After the update, we need to change our GUI, recover, update. The button show different ways. We need to go back to the previous way. Yeah. So that's the update function. Yeah. All right. Then there is another function I want to explain, delete function, delete this row. Yeah. Here you can see both edit and update, these two JavaScript functions, I use Ajax. See, here I use the special Ajax object. This is Ajax object. Communication between client server, and we do not refresh the page, right? Yeah. We do not reload the page. Yeah. That's Ajax way. But let's think about deletion. We delete one row. Okay? When we delete one row, then this time if you use Ajax, it may not be convenient. Because with Ajax, you need to, after deletion, you need to modify your GUI display part, right? When you modify display part, a little more complicated. Yeah. So here I do not use the Ajax. Yeah. So here after the deletion, I reload the page. Yeah. This is so document.location.href. Then I make the web browser. Because this function. Yeah. So we make the web browser to display this URL. When we force the web browser show this URL, then that's the reload the page. Yeah. We reload the page. Yeah. Yeah. Because that's simple, right? When you reload the page, you don't need to modify the GUI in a complicated way. Yeah. Because after deletion, when you need to modify the page using Ajax, the logic is relatively complicated. Yeah. A little messy, although it's doable, but a lot of work. Yeah. So here, yeah, I just do the simple way. Yeah. Let's reload the page. Okay, no problem. Yeah, here, let's reload the page. Yeah. After deletion. Yeah. Yeah. Okay, yeah. So that's another thing. Then, yeah, Oh, okay, yeah. Yeah, here, yeah, because my recording machine is there. So I do not worry about this machine. Yeah. Then the last thing, yeah, before I finish today, remember there is a transcript page, right? Yeah. In my sample project, I also give you this display transcript PHP file. Yeah, I can explain a little bit. Yeah, because for the transcript, we need to display. Yeah, this is our project description. This is our project description. Yeah, so I cut a screenshot from our textbook. This is the format of transcript. So for different students, each student, you need to display the transcript information. Okay, transcript information. Yeah. So then, in our PHP file, actually the HTML table structure. Yeah. So we need to do a nested for loop. Yeah. Here. All right. So here, this is the transcript file. All right. First, we need to retrieve all the students. Yeah. So the first query, that's the outer query. Outer query, we need to retrieve all the students. Okay. Yeah. Yeah. Because each student, we need to use one block area to display the transcript information. Then, after that, yeah, so then we display the table header, the part. Yeah. After the header part, we need to use so here, while loop. So here I use while loop. Yeah. Because we need to do an inner query. Yeah. Inside that outer query, yeah, we need to do an inner query inside. Oh, yeah, actually, yeah, this while loop, we do the iterations going through all the students. Each iteration corresponds to one student. Okay, one student. All right. All right. Then, for each student, yeah. So we retrieve row. Yeah. All right. Yeah. The transcript. Yeah. So we need to get the student name, student number, the student information. All right. After that, we need to run another query in this while loop. All right. This query, we need to get the transcript information. The transcript information, we join two tables, section table and the grade underscore report table. Two tables. Okay. Yeah. So then we get the information. The student number equals $student underscore number. This value from the first query. First query. So we get that whole block transcript information for the current student. Yeah. So then, yeah. Yeah. All right, run. Then for the display. Yeah. For the display part, yeah, here. Yeah. Although here you can see I display two parts. The first part is one row, okay? Yeah. Because after you retrieve the data, the first row I retrieve, display here. Then I use a for loop to display remaining rows. Yeah. Although some of you may feel, why we just use one for loop to display all of them? Yeah. Yeah. So here, because the first row, we need to store some special information. First row, the row span, we need to count the number of rows. We need to set that row span, right? Because for other rows, we do not have that part. Yeah. So that's why I take the first row out. Yeah. Because the setting for the first row is different. Yeah. So that's why. Yeah. After that, for the remaining rows, yeah, we use the same way. So we use this for loop to display the remaining rows. Yeah. Yeah. So here we use the associative array. Yeah. The field name, yeah, we can use field name to retrieve the data. Yeah. All right. Yeah, so that's the transcript. Okay, yeah. Yeah. Otherwise, yeah, so, yeah, but for your implementation, you do not need to do anything on transcript, right? Yeah, so here, just help you understand. For your own implementation, you do not need to do anything on it. Yeah, you just do the, our requirements. Yeah, new features. Yeah, requirements. Yeah. All right. So that's I think you should be able to understand all the sample code. Yeah. All right. Then remaining work. Yeah, I hope you can handle. Yeah, the final and last project. Oh, for the final, yeah, one more thing. Yeah, we know it is 1 week from Thursday, right? 1 week from Thursday. And remember, we split the final in two parts, part A, part B. Yeah. So you will do part B in class, 2 hours. Yeah. Yeah, but the part A, I will make it in Canvas, as in the Canvas quiz format. Yeah, you did many times. But this time, I do not call it quiz number 6. Yeah, remember? Yeah, I remember in the syllabus, I only give you 5 quizzes, right? Yeah, yeah, as I remember, 5 quizzes. So our part A, I will not call it quiz 6. I just call part A of final exam. Okay, but the format still quiz format, 10 questions, 10 concept questions. Yeah. And I want to make it also available on the final date. Yeah, make it available final date. That is the 1 week from Thursday, December 18th. Yeah. December 18th, after your part B. After your part B, then I show the part A, the quiz. Then give you several days. Yeah. So Thursday, Friday, Saturday, yeah, or Sunday. Yeah. So it's okay. Yeah. But you may not need that many days because part A relatively easy. Yeah. Pretty easy, part A. Yeah. All right, so that's pretty much everything we have this semester. Yeah. So Thursday I will, go through the quizzes and homework assignment 3B. Yeah. Now 3B. Let me look at how many questions you have in this assignment. If you have a lot of questions, yeah, in my grading, I will spend all the time on the query questions. If you do not have many questions, then I may spend some time on the previous quiz questions, explain a few previous quiz questions. Yeah. All right. Yeah.